Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about UVM Factory. So in our previous video, we have discussed about why we need UVM Factory. So we have basically laid a foundation of why we need a factory. We have seen one example in system Verilog. Now in this particular example, we will see how and what is UVM Factory. So the UVM factory is a fundamental part of UVM and that enables the dynamic creation of objects and components in UVM test bench. So basically it provides a standardized way to instantiate verification elements, allowing flexibility, reusability and configurability. So the UVM factory is a mechanism in UVM that is responsible for creating UVM objects, UVM components dynamically. So instead of using the traditional new method like in system Verilog, we are going to use factories create method and we are going to register, and that allows polymorphism, factory override, that and all we are going to see them without changing the source code, So it basically allows object-oriented programming and it allows such as polymorphism, and it enables factory overrides that we are going to see. And it also helps us to create reusable and configurable test benches by enabling easy modifications. Coming to the need of UVM factory, in our previous session also we have seen. So basically in traditional system Verilog test benches, we use new method to instantiate objects, but this approach has limitations when applied to a complex verification environment. So the UVM factory solves these problems by providing dynamic and flexible object creation. Coming to this factory coding convention, so basically a component or an object must contain factory registration code. Okay, so you take any component or any object, it must contain factory coding. You must always register your class. It may be a component class or it may be an object class with your UVM factory. Okay, so how we are going to register our class? Let's say if I have a class which is known as let us take a component class my underscore component, which is extending from UVM component. As I've told, we should always extend from the parent classes. Okay, I'm extending this from the UVM component. Now I have to register this particular UVM component with my factory. How I am going to register? So what I'm talking is the first way for registering my UVM is my registering classes with my UVM factory. Now this is case one. So in this case one, we are going to use a class which is known as UVM component registry class. Okay, so basically we are going to use a class which is known as UVM component registry class for registering our component, that is my underscore component. This is our user defined class. This we need to register it with our factory. For overriding to be performed, the first step you should do is register the user defined class with the factory. So this is the mandatory thing we should do. Okay, so now let's see how to register our user defined class with the factory. So the syntax what I'm going to do is I'm going to use my type def and I'm going to call my UVM component registry class. I'm going to use my UVM component registry class. It is a parent class, factory class, UVM component registry. It's a parameterized class. So I'm going to provide my class name, that is my underscore component, and I'm basically wrapping this entire class to my type underscore. So I'm using here type def. I hope you already know what do you mean by type def. If you don't know, please refer in system Verilog playlist. So I'm basically creating my new data type using this particular type def UVM component registry hash my component type ID. So if I use this, I don't need to write everything again and again. I can simply use this type ID instead of this UVM component registry hash my component. Right now here I'm going to use one more function which is known as static function ID get underscore type, and it is going to return type ID of get and followed by end function. So basically what we are doing here, so we are creating a static function and this function is returning your type ID instance, this instance, your registry class instance, and the function name is get underscore type. Now, in this particular thing, what we are written type underscore ID scope resolution operator get. So the scope resolution operator is used for calling the static methods. So basically there is a method which is known as get inside your factory class. So basically what we are doing, we are using this particular class, we are calling this particular get method. Okay. So it is going to get the, we are going to get the instance of this particular factory. Okay. So that particular instance, it will be written. So this is how we are going to register our class with the UVM factory. So this is how we are going to register our class using the UVM factory. And remember this method, we are going to use it when we are using our using our UVM factory override method. We will use this particular method. Okay, so this is how we are going to create our register uh, our class with our UVM factory. Now, so instead of writing this everything, we can use macros. We can basically use our macros. So how to use this macros? So these are your UVM macros. So instead of writing that few lines of code, that four or five lines of code, this lines of code, what we can basically do is we can use this particular macros for registering your classes. It may be a component class or it may be an object class. You can use this registration macros. For registering components, you have tick UVM underscore component underscore utils, and you will write your class name. Okay. And this is for your component classes. And for parameterized classes, this is the uh, syntax tick UVM underscore component underscore param underscore utils this underscore t. Okay. So basically you are using type def, and this is your class name, which is a parameterized class, and you are using type def, you are creating a new data type this underscore t, and you are using this underscore t here. Okay, instead of writing everything inside this, or else you can write this like this also, tick UVM underscore component underscore param underscore utils. You can write down entire class name, my underscore param underscore component hash int hash at add underscore width comma data underscore width. So instead of writing this entire line, you are using type def and you are simply using this underscore t. So this is how you can register your component classes and parameterized classes with the factory. And let's say if you want to register your object classes, see, so this is your object class which is extending from UVM underscore sequence underscore item, which is an object class. My underscore item is your class, and which is extending from UVM underscore sequence underscore item. So if you want to register this particular class, you are using this particular macro, which is nothing but tick UVM underscore object underscore utils my underscore item. So instead of writing all these lines of code, you can simply use this particular macro. And for registering parameterized classes, same tick UVM underscore object underscore param underscore utils, you are using this underscore t. Okay, so this is how you are going to register your components and you are going to register your objects with the factory. Now, after registering your components or objects with the factory, now you have to create the instances of these classes. Now, in system Verilog, we use it to create the instances of these classes using the new method. Yes, yes or no? Yes. So basically, the UVM component and object constructors are virtual methods. Normally, in system Verilog, when we were discussing, we were creating the objects of your classes with the help of your new method. With the help of new method, we were creating the instances. But in the case of UVM, for UVM components and UVM objects, the new constructors are virtual methods with a prototype template that must be used by the users. So basically, both the UVM components and objects classes have virtual constructors in the sense that their subclasses must be a specific constructor signature. So these constructors follow a standard prototype. So these constructors will have a standard prototype, and so that factory system can construct them correctly. So this arguments, the constructor new cannot have any argument. It will have only a specific arguments that the user should always give. Okay, so in order to support deferred construction during the build phase, the factory constructor should contain defaults for the constructor argument. What is meant by deferred construction? That means UVM doesn't immediately construct an object when it's declared. it delays it until needed. So example, during the build phase. So during the build phase, everything we are going to see. So for making this work, the class constructors must use default arguments. So what are the default arguments? For a component, the default arguments are string name, that is the component name, and the component parent, UVM underscore component. So these are your default arguments for your component class. And for your object class, there is only one argument, that is only the name. There is no hierarchy for objects, right? So that's why we are not writing UVM component parent. Okay. So these are the functions. These are your constructors, which are already declared in your parent classes. That is UVM component and UVM underscore sequence item. These are already declared as virtual. So you need to write down the template. Okay. So this is how we are going to use them. We are not going to use the new method for creating the objects. Then what we are using? So we are using create method of the factory. So we are going to use create method for creating the instances of this objects or the components. So the create method is a factory method used to construct an object or component dynamically during the simulation without directly calling the constructor by ourselves. And it's a part of factory design pattern in UVM, which allows flexible and overridable construction of objects and components. So this particular code is going to be present, this particular driver instance, we are going to create it in the agent. So this agent, we already know it is going to contain driver, it is going to contain monitor, sequencer, right? So this particular agent, in this particular agent code, we are going to create the instance of your driver. So this is my underscore driver is the driver name, followed by drv is your handle name. So what we are basically doing, we are writing down drv, which is a handle name. My underscore driver is a class name. Okay, my underscore driver is a class name, and scope resolution operator type underscore id. So if you carefully observe the code which we have written in our previous slides, so where is it? Yes, this one. So this is your my underscore component. Now in my underscore driver also, in the component class, you are writing your factory registration code, and you should register your driver also with the factory. So there also you are going to write this particular code, or else you can use this macros which we have discussed. So if you are using this particular driver, this particular thing, or if you are using your macros, if you carefully observe, there was a type ID created. There was a type ID. Type ID is nothing but it's a data type. It's a wrapper around this particular component registry class, right? So you are going to use the scope resolution operator. So you are going to use my underscore driver, this particular class. You are going to access this particular type ID, and you are basically accessing using the scope resolution operator. You're going to call this particular create method, which is present in the UVM component registry class. Okay, which is this particular create method is present in the UVM component registry class, and you're providing the handle name and the location. Okay, so this is your handle name. So this is basically creating the object for this particular handle. Okay, this is basically creating the object for this particular handle, and this is how we are going to create the object for this particular handle drv. Okay, so using the create method, we are not going to use a new method. We are basically using the create method for creating the instance for your components. Okay, now, and for objects, so this is the syntax for writing for objects. So tx is equal to my underscore sequence underscore item is a class, and inside this class you are going to call this type id, and inside this type id you have the create method, and you have the create method, and using this particular create method you are creating the instance for this particular thing. Okay, so this is how you are going to create the instances for your components and for your objects. Let's see, after registering your components or objects, and after creating the instances, let's see how to override your components. Example here, let's say if we have an agent class, so let's say this has your base agent. Okay, if we have agent class which is known as base agent, and if we have one more class which is known as base agent 2. Okay, we have two agent classes, one is base agent 1 and another is known as base agent 2. Okay, and these two are being derived from one more agent class which is known as, let's say, base underscore agent. Okay, so let's say this has only agent 1, agent 2. Okay, From this base agent, we are deriving these two agent classes, agent 1 and agent 2. Now, from this agent 1 class, now let's say one more class has been derived, which is known as child underscore agent. Okay, let's say if we have declared this particular child underscore agent which has been derived this particular from this particular agent one class. Now let's say if I want to replace this child if I want to replace this agent one and agent two with this child underscore agent, I can use this particular factory override method. Or if I want to replace only agent one with this child underscore agent, like this also I can do. Or else if I want to replace all the agent classes, if I have n number of agent classes, I can replace all those agent classes with this particular child underscore agent, then also I can replace. So basically there are two type of factory overriding methods. One is global override and another is known as instance override. So basically one is known as global override and another is known as instance override. In the case of global override, you are basically overriding all the instances which are present with your required instance. And in the case of instance override, you are basically replacing or you are basically overriding whatever the instance you needed with the required instance. So this is the difference between your global override and instance override. Now, how to perform this particular global override? So we have a syntax for performing global override. I will write down here. So for performing global override, we are going to follow the syntax which is known as set type override by type. Override by type, and here we are going to provide our UVM object wrapper, and here we are specifying the original type which we want to replace, which is present. Original type scope resolution operator, get underscore type, get underscore type, and comma, and we should write down the substitute type with which we need to substitute underscore type scope resolution operator get underscore type. Okay, so this is the syntax which we are going to follow, and there will be one more argument which is known as replace of type bit. Okay, this will be by default one. Now let's try to understand what is this. So this particular this here the original type is nothing but this one, the agent one and the agent two. Okay, this is nothing but your agent one, agent two. Okay, so let's say if we want to replace this agent one with this child agent, you are going to write it down. Okay, so basically if you want to replace it, you are going to mention the original type which you want to replace it. So in this particular thing, so wherever that particular component is present, that is replaced by this particular substitute type. And what about this get underscore type? Have you seen anywhere this particular get underscore type? Yes, so we have seen this particular get underscore type. Where we have seen this? So here we have seen this particular get underscore type. Where here? So when we are writing our component registry code, here we have seen our get underscore. Here we have declared our static function type ID get underscore type. If we are going to call this particular get underscore type, it is going to return the instance of this particular component registry class. Okay, it is going to return the instance, and this instance, it is a singleton instance. It is a singleton instance. That means for a class, it is only going to have a single instance. That's it. Okay, so this is going to return this particular singleton instance. So what is happening here, if we are calling this particular get underscore type, it is returning this particular instance, and we are calling this substitute instance. So we are replacing this original type instance with this our substitute instance agent 2. And if you are using global override, the base driver which was present in agent 1 and agent 2 was replacing by your driver underscore 1, right? Now let's say if you have base driver in your agent 1 and if you want to replace only this base driver which is present in agent 1, and if you don't want to replace this agent 2 base driver, okay, by driver 1. Now in this particular case you can use instance overriding. Here in this particular case we can use instance overriding. Okay. Now, how to use this instance overriding? We will simply write set type override by set instance override by type. Here, not type. It is instance override by type. We are basically specifying the path, and again the original thing is base underscore driver, base underscore driver, get underscore type, and followed by comma. You want to replace the driver underscore 1, we will call the static method get type. And here we should mention the path where our driver base underscore driver is present. Okay, in which path exactly we should specify it. In this particular example, environment dot agent handle. Okay, agent handle, in that particular thing your my underscore driver is present, so there you can replace it. So this is how we are going to replace. Now there is one more argument which is known as bit and as bit replace. So what do you mean by bit replace? So if this particular bit replace it is equal to 1, that means it is going to replace any existing override. So if previously any overriding has been happened, then also you can perform the overriding again. But if your bit replace is equal to 0, that means if any overriding has been happened in the past, then your current overriding, if you are trying to override at present, then that particular thing will be ignored. Okay, so that is the use of this particular bit replace. So this is how you are going to replace your components or override your components. You should definitely register your classes. It may be any component or any object. You should definitely register those classes. Okay, you can follow the macro method or the lengthy method, and you should register the classes. Then after only you can override those components. You can override those components. Yes. So this is about UVM factory overriding. So that's all for this particular video. In our next session, we will see this particular example with the help of coding. Yes. So that's all for this particular video. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.